Hi everyone. Today we're going to talk about how to write the equation of a parabola in a different way that you have not seen before. So you've seen parabolas or quadratics in what we call standard form in the past, but today we're going to talk about it in a different form. So here we go. First, I want you guys to look. You're going to be in classwork. It's going to be called day 20 and 21. It's going to be parabolas with focus and directrix. So I do want to mention that. All right, so first I want you to look at this do now, and I want you to try this on your own very quickly. Pause the video here, and then we'll talk. Okay, so if you did the first part A, it said identify the transformations from the parent function y equals x squared, which is your basic parabola, to this equation f of x. I'm hoping you said it went to the right 3 and up 1. So remember, if your basic parabola is the vertex is 0, 0, which is the origin, this means that this new vertex is going to move 3 to the right, 1, 2, 3, and up 1. So the new vertex is going to be 3, comma 1. This is called vertex form. Vertex form of a parabola is where you can see the vertex by just looking at it. So you can see that you do the opposite sign of what's in the parentheses for x, and then you keep the sign for what the outside number is, which in this case is 1. So if we go to 3, comma 1, and then we were to do a sketch, if it's a positive parabola, meaning that the value in front, which is the leading coefficient, it's not there. So it's a positive 1. So that means that it's a positive x squared. It's going to go up or open up. So we're going to open up like this. Okay, there you go. And there's your vertex 3, 1. Now, if I wanted to find the inverse, I'm going to call V for vertex, by the way, today. The inverse f negative 1, what I would do is switch x and y and solve for y, which we just did in this past unit. So when you switch x and y and then you solve for y, you subtract 1. And then when you take the square root, you have to remember that because the index is 2, that it could be a plus or a minus answer. So I have a plus minus in front of my radical. Did you remember that? And then plus 3. So now just keep in mind, if I had graphed this, what would it look like? If you don't put the plus or minus, you're only going to get the positive piece of the parabola. So for example, the point 3, comma 1, when you reflect it, is going to be the point 1, comma 3. That's going to be the new vertex. And that 1, comma 3, then it's going to open up to the right. And if you only do this positive part of x minus 1, like x minus 1 plus 3, if you were to just graph that in y equals, you're only going to get this positive piece right here. So if you put the negative in y2, y1, y2, negative radical x minus 1, then you're going to get this net bottom piece here. And that's going to be the full inverse, f negative 1. So what we see is when you have x squared, which is the original parabola, it opens up or down. And because it was positive, the parabola opened up. That was called f of x. But when we did the inverse and we switch x and y, we end up getting this sideways parabola, which looks like a C. And basically now you see the inverse, the equation became y squared. So when y is squared, it turns out that the parabola is going to open right or left. And in this case, it opened to the right. So it opened up with x squared, but opened right with y squared, positive y squared anyway. So notice also the vertex of this change. So before the vertex was change the sign here, 3 and then the 1, 3, 1. But here the vertex winds up being 1, 3. So you take the 1 here and then the 3 from the y. So that's kind of interesting. And we're actually, I'm sorry, you're actually going to see that today. Okay, so now I'm going to actually just jump to basic equation of a parabola. And if I were in person, I would show you some cool things, but I'm not. So I'm just going to go over. The parabola is defined as the set of all points in a plane that are equidistant from a point called the focus. So this point here, which I'm going to highlight in yellow, is called the focus, and a line called the directrix. Directrix is right here. I'm going to highlight it in yellow as well. So basically, if you learn locus of values in geometry, hopefully you learn that all the points that are equidistant from two things are the midpoint. And if you were to draw this whole thing in here, basically, if you're anywhere on this parabola, you're going to be equidistant from this line this point called the focus, and this line called the directrix. So let me fill out this line real quick with the vocabulary, okay? And then I'll explain. Okay, so the point called the focus is always inside the parabola. I want you to picture me shining a flashlight and shining my light onto the focus. So the focus is always like what our parabola opens toward. So here's our parabola, it's opening up and it's opening toward our focus. So think about like you're always looking toward your focus, whatever that is in life. That's your focus. The parabola looks toward the focus. And then the line in the back of the vertex is the turning point, is called the directrix, which I just usually label as T, V for vertex, and F for focus. The vertex is always in the middle. So the parabola is a set of all points in the plane that are equidistant from a point called the focus and a line called the directrix. So a directrix is a line. It's either a vertical line or a horizontal line. In this case, this is a horizontal line, so it would be y equals. The focus is always located inside the parabola, which is what I said before. The directrix is always located kind of behind the parabola, behind the vertex, like it's outside the parabola, not inside the parabola. And the vertex is always the midpoint, which is the middle point um, uh, in the middle of the focus and the directrix and located on the parabola. The vertex is always on the parabola, okay? It's called the maximum or the minimum of the path. So the vertex is a point equidistant from the focus and the directrix. The vertex always lies on the axis of symmetry. I don't know if you guys learned axis of symmetry in the past, but axis of symmetry is, in this case, a vertical line here that if you folded the parabola in half, that it would be symmetrical around. So the vertex is always on that. And then the distance between the vertex and the focus and the vertex and the directrix. Let me do, man, I'm running out of colors. Let me do black here. This distance from here to here is equal to this distance from here to here. And the letter we use is the letter lowercase p. So I'm going to put P, P, okay? PP. All right, so now we're actually going to do questions. Here we go, turn the page or scroll. All right, so if you look at this picture, it says vertex. So look for the turning point. Here it is. Label it. It's 1, 4, right? All right, so where's the focus? I don't know yet. I have to first find the directrix. So the directrix is more obvious here. It's this line. It's a horizontal line passing through y equals 2. And because that's labeled, I'm going to write that in next. Now, to get the focus, I first have to find the distance from here to here, because this is called P, and I need that to figure out where the focus will land. So the distance between 4, which is the vertex, and 2, which is the directrix, is P equals 2. So I would write down P equals 2. So now what you have to do is just go 2 units up from the vertex to get your focus. So go up 2 units and be inside the parabola, and 2 units up from 4 is 6. So the focus is going to lie at 2, 6. So notice that, oh no, sorry, 1, 6. The x value should remain the same for the vertex and the focus. It's 1, 6 or 1, 4. But the only thing that changed was that the y coordinate got added by 2, which was the p. Okay. All right, let's do another one. This one's actually opening to the left this time. The vertex, let's go to that first. Looks like -4, 2. Okay. The directrix is a vertical line here. It looks like it's passing through -3. I'll do it in red. And because it's a vertical line, it's going to be x equals instead of y equals. X equals -3. And then if you look for the distance from -3 to -4, that distance is called P, which is right here. It's tiny. It's P equals 1. So if you go the other way to the left, from the vertex to the left, you're going to get -5, 2. That's the focus. -5, 2. So we just went 1 unit to the left from -4. All right, we're getting there. We're getting there. Now let's actually do a Regents question. A parabola has a directrix of y equals 3 and a vertex of 2, 1. What is the focus? Okay, So my best advice for all these Regents questions is draw the picture. Like, do not get lazy. Draw the picture. Like, please draw the picture. Draw the picture. Okay. So first, let's go to y equals 3. So go to the y-axis, go up to 3, and put a line going across. You could do a dotted line or a solid line. I don't really care. I'll label it y equals 3. And I also recommend that you actually do your slashes so you can know how to count how many units you counted. So that's your directrix D for directrix. Now the vertex is 2, 1. So go to 2, 1. Okay. Make a V for vertex. All right. Now you have to figure out where is the focus going to lie. Remember, it's always DVF or FVD. The vertex is always in the middle. Just like when you guys did geometry, the vertex of an angle was always in the middle. If you did like ABC, it was angle B in the middle. Same, the vertex is always in the middle. So if you remember that, then what you need to know is if this is the directrix and this is the vertex, then the focus has to be on the other side, it has to be under the vertex. So first what I want you to do is count how many units there are from here to here. So how many units from 1 to 3? Count if you have to. You should see that that's 2. So that's called P. P equals 2. Write that down. P equals 2. And now what I want you to do is go 2 units the other way from the vertex. So if the vertex is the midpoint, you have to go 1, 2, 2 units down. So we're at 1, then we go to 0, and then we go to -1. We should be somewhere over here, F. And then if you want, you could draw the picture. Remember that the parabola always starts at the vertex, which is the turning point, and it always looks toward the focus. So you always want to open toward your focus. Remember, look toward your focus. So now, once I have my beautiful picture, I can find my coordinates of my focus, and it's going to be 2, -1. So, you know, the x value always remains the same. The 2 is the same for all these choices. But you just have to figure out, are you moving up, down, right, or left from there? And again, my best advice is draw the picture, draw the picture, draw the picture. Now, let's talk about the equation. Now, this equation is called vertex form, which I talked about in the do now. The only difference from the do now to this is that you have a coefficient here, which I'm going to highlight for you guys in aqua. Okay. All right. First, let's start with x squared. When x is squared, meaning the x value is in the parentheses that's squared, then the parabola opens up or down. If the coefficient, which in this case is 1 over 4p, is positive, the graph opens up. So positive x squared, the graph opens upward. If the coefficient, in this case -1 over 4p, is negative, so it's a negative x squared, the graph opens down. Okay? Don't worry about the 4p yet. All right. Now let's talk about right and left. Let's say y is squared. Look, now y is squared. Remember in our do now when we had y squared, when we switched x and y, the parabola, which was the inverse of the original, opened to the right. So notice that here, if we have positive coefficient and positive y squared, this opens to the right, which is like our do now. And negative y squared, negative coefficient, leading coefficient, it opens to the left, okay? So just look for the sign pretty much like tacked on to the front of the parentheses or whatever the coefficient is, and that's going to tell you if you're going right down, positive or negative, up or down, right or left. And then if x is squared, it opens up or down, and if y is squared, it opens right or left. Okay, so now let's say I wanted to write the equation given some piece of information. The first thing I want to do is draw a picture, like I said, and sketch whatever I can, figure out if the graph is opening up or down or right or left, determine the sign. So if it's opening up, it would be positive, down, negative, right, positive, down, left, negative. And then I can use the vertex as well. And also I want to make a note, you want to find P, which is part of number 1. Find the value of P from your picture, because then when you do your equation, if you look back at the previous thing, the coefficient is always 1 over 4 times p. So you have to do 1 over 4 times whatever the p value is. All right, let's do an example. Here we go. All right, so first ask yourself, does this parabola open up or down, right or left? So it opens up. So we want to say it opens up. And since it opens up or down, it's going to be x squared, and it's going to be positive leading coefficient, okay? Because it opens up. Now, what is the value of the vertex? So go here. The value is 3, -2. Write that down. And then find the value of p. So to get the value of p, you're going to count how many units up or down from the vertex to the focus or from the vertex to the directrix. And it should be equidistant. So it should be the same number of units if you go up from the vertex to the focus or down from the vertex to the directrix. So let's do it. 1, 2, 3, p equals 3. 1, 2, 3, p equals 3. So write down p equals 3. Okay? The whole distance from the focus to the directrix is 6, so half of 6 is 3. Now we're going to write our equation. So if you go back to the previous, here, the bottom here of this page, it says it's y equals 1 over 4p x minus h squared plus k. Okay? All right. It might be hard at first, but you'll get the hang of it. 1 over 4p x minus h squared plus k, where the h and the k are the vertex. Okay? So think about your transformations. Let's start with the vertex. Think about your transformations from Arduino. This went right 3 and down 2. Right 3, down 2. So look, right 3, down 2 from the origin. Right 3, down 2. So what's it going to say here? It's going to say x minus 3, because you have to change the sign of the x coordinate of the vertex, squared. And then down 2 is going to be a minus 2 in the back, because remember, we keep the sign of what's on the outside. And then we have to put our p in. So our p is 3. So you're just going to throw a 3 in there. And then if you want to clean this up, we're going to rewrite 1 over 4 times 3 as 1 over 12. So you're going to write 1 over 12 x minus 3 squared minus 2. Okay, there it is. That's that equation. And if you're not sure, put it in your calculator and check and see if the picture you generate is the equation that you made. All right, let's do the next one. Here we go. Is opening up or down, right or left? I'm hoping you're saying it's opening to the right. So if it opens right, and it's going to be positive y squared. So that's the first thing. All right, look for the vertex. Write it down. The vertex is going to be -3, 1. And then find the p. Right 2 and left 2 from the vertex. Okay, so let's go back to our initial shell here. So notice the equation is this one here. I'm going to do a circle here. 1 over 4p y minus k squared plus h. So it's x equals, instead of y equals, 1 over 4p y minus k squared plus h. So the h and the k are switched, just like they did on our do now with the inverse. So x equals 1 over 4p, p is 2. So 4 times 2. Okay. Now the h and the k are a little confusing because the -3, which is the vertex, the x is going to go over here. And then the y is going to go over here. That's where it gets confusing. So the -3 stays the same, but the -1 changes because it's in parentheses. So the final answer is 1 over 8 y minus 1 squared minus 3. And that's because I had to put the h, which is the x, on the outside because the h and the k switch. And then I had to change the sign within the parentheses also. So that one is a lot harder. I'm going to star that one. I'm going to tell you that's less on the region. So I would worry more about like something like this. Okay, so let's take a look. Which equation represents a set of points equidistant from the line L, which is the directrix? So you can write D for directrix, and the point R, which is the vertex. Okay, so remember, equidistant means basically find the midpoint between these first. Okay, so count how many total units, 1, 2, 3, 4 total units, and then half of that would be your midpoint. So half of 4 is 2. Sorry, this is the focus, F for focus. So we just found the vertex, which is the midpoint, B. Now, is this parabola going to open up, down, right, or left? I'm hoping you remember that you draw your parabola from your vertex, which is your turning point, and then look toward your focus. I'm hoping you remember your directrix is always outside the parabola, never inside the parabola. So you always look toward your focus. So I will write down P equals 2 because it's 2 units up or 2 units down from the vertex to the focus or the vertex to the directrix. And then I would also write down this is negative x squared because it is x squared because it opens up or down, but it's negative, okay? Now, if you look at all the choices, they all have negatives in the front, negative, 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 negative. So that's really not going to help us. Also, they all have negative 1/8 in front. So like that's also not going to help us, but let's talk about it. 1 over 4p x minus h squared plus k, right? So where does that 1/8 come from? 1 over 4 times p, which is 2. There's the 1/8. Remember, it's negative because it's going down, so negative 1/8. Okay, x minus plus k. Okay, so think about the transformation again. It went right 2 and down 1. Right 2, down 1. Right 2, down 1. Right 2, down 1. So it's going to be x minus 2 squared, and then minus 1 on the outside, because remember, you change the sign of the x, but you keep the sign of the y. So the final answer should look like this. Let's see if we have a choice. X minus 2 squared minus 1. That is choice 4. So I do want to mention that you could put all these choices in y equals and then graph all them and see which one will look like your picture if you do the picture. All right, next one. Let's see if you can do it. So I want you to first sketch it and then find the value of p and then see if you can pick your answer. Pause the video here. Okay, so I'm hoping you started to draw this and you labeled V for vertex and F for focus. I'm hoping you counted the number of units from V to F and realized that it's actually 4 units. P equals 4. So if you did that, great job. Now go 4 units up from the vertex. And 4 units up from 1 is 5. So your directrix should be y equals 5. Now make your parabola go down like this. I'm hoping you drew this picture. Now, if you didn't already, stop the video here and pick a choice. Okay, so did you pick choice 3? If you did, you're right. And let's talk about it a little more. If you know it's negative because it's going down, you could cross out choice 1 because that one's not negative. Next, you know you have to use your vertex, so it's got to be x minus 2. So then you could cross out choice 2 because that's plus. It went right 2 and up 1. So it's going to be a plus 1 in the back. Good job. All right, look at the next one. Give it a try, and then we'll reconvene. So for this one, did you realize that, I don't know if you realize, the vertex goes in the middle. So remember, it's FVD, it's FVD, or DVF. Vertex goes in the middle. So right now we have a focus that lands at 6, and directrix that lands at 4. So really that's only 2 units, and the vertex will land in the middle at 5. So did you realize that the vertex is going to land at 0, 5? That's the first thing I want to mention. Then is this going up or down? I'm hoping you're going to say it opens up. So if you know it opens up, then it's going to be positive x squared. If it's positive x squared, you could cross out choice 3 and choice 1. And then we can start to write our equation. All right, you know the answer has to be choice 2 because choice 4 has a 6 in it, right? But now let's talk about why it's a little different. Do you see how choice 2 does not have it in y equals form? Let's say you wanted to write it in y equals form and then transform it. You could either write it and then transform it, or you could look at this one and solve for y. Maybe we'll do it that way. To solve for y, we could divide by 4. And then you're going to get 1/4 x squared equals y minus 5. And the last thing you're going to do is add 5, and you're going to get 1/4 x squared plus 5. Okay, so this is really 1 over p, 4p. So what's p? P is actually 1. So 1 over 4p would be 1 over 4 times 1, which is 1/4. The 0 comes from the fact that you have 0, 5, so you don't really have anything attached to the x squared, and then plus 5 on the outside. All right, last one. Give it a try, and then we'll reconvene. Okay, so did anyone draw a picture like this? Did anyone find their vertex to be 4, -1? I hope you said yes, and I hope you said your p equals 2. So now it's negative because it's going down, and it's negative x squared. So right away, without even knowing like what's up with this stuff, you could cross out choice 1 and 3 because they don't have a negative coefficient. Okay, so now what you want to do is you're going to do your 1 over 4p. You're going to write y equals -1 over 4p. P is 2, so that's -1/8. X minus 4 squared minus 1 because it went right 4 and down 1, right 4 down 1, right 4 down 1. So you get -1/8 x minus 4 squared minus 1. And now you may see that that answer choice is not there. So you have to think about which one it is. So if you look at choice 2 versus 4, the answer is going to be 4 because it looks like they put the y plus 1. They put the plus 1 on the other side. See? Plus 1, plus 1. Okay? All right, try the rest of the Regents questions. Go!